Yeah, those who are online are able to hear me. Shall we do some problems? For that, just give me a minute. Just today's date. Yes. So yesterday we discussed the concepts which are related to motion in one dimension. Today we'll try to solve few problems that are based on them. So the first question is, the displacement of a particle moving in a straight line is given by the expression x is equal to at cube plus bt square plus ct plus d in meter, where t is measured in seconds and abc are constants. The ratio between the initial acceleration and initial velocity is. So given data is x is equal to at cube plus bt square plus ct plus capital D, where t is measured in seconds. So ratio between the initial acceleration and initial velocity. So if I take dx divided by dt, this is going to give me velocity. So what is dx by dt here? It is going to be a into derivative of t cube is 3t square plus b into derivative of t square is 2t plus c into derivative of t is 1 plus derivative of capital D is 0. So this will be 3at square plus 2bt plus c, which is v. So since they asked initial velocity, so for velocity to be initial, t should be equal to 0. So if you substitute t is equal to 0 here, you will get the velocity at time 0. So v of 0 is what we write it as. So v of 0 is going to be c. Let this be expression number 1. Suppose I differentiate this, I'll call it as star. Suppose I differentiate the star with respect to time, then I will get d square x divided by dt square, which is called as the second derivative of displacement with respect to time. Then this can be called as acceleration, and acceleration is obviously going to be equal to 3a into derivative of t square is 2t plus 2b into derivative of t is 1. So this is going to be 6at plus 2b, which is the acceleration. So if I take the acceleration at t is equal to 0, I'm going to get 2b. So let me call this as 2. Now, if you observe the question, they're asking the ratio of the initial acceleration to the initial velocity. That is, we need the value of 2 divided by 1, which is equal to 2b divided by c. So if you check this, 2b divided by c, option D is the right answer. Make a note of this. Is it clear? So those who are online, is it clear?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. We'll proceed with the next problem. The slope of tangent drawn on the velocity time graph at any instant of time is equal to instantaneous. So if you have velocity time graph and you have any curve, the slope of the tangent drawn to the curve at any instant gives, the slope of this line gives instantaneous acceleration. The relation between time and distance is t is equal to ax square plus, t is equal to alpha x square plus beta x, where alpha and beta are constants. The retardation is. So given t is equal to alpha x square plus beta x, right? Now, if I differentiate with respect to t on both sides, then I get derivative of t as 1 is equal to alpha into derivative of x square is 2x into dx divided by dt plus beta into dx divided by dt. So this is called as chain rule. Okay. So this I can write it as 1 is equal to alpha into 2x into v plus beta into v. Again, if I differentiate with respect to time on both sides. So again, if I differentiate with time on both the sides, derivative of 1 is 0. This is equal to alpha into derivative of 2x into v is what? So it is, okay, I'll do one thing. I'll take this 2 outside. So 2 alpha into derivative of xv. We need to apply product rule. So x into dv by dt plus v into dx divided by dt plus beta into dv divided by dt. Now, if you observe this, I get 0 is equal to 2 alpha into x into dv by dt is acceleration plus v into dx by dt is going to be velocity plus beta into acceleration. Okay. So this I'll get 0 is equal to 2 alpha into ax plus v square plus beta times a. Now the parameter that I need to eliminate is, I need to understand what is alpha into x or a into x for that matter. One minute. So I think there is something missing in the question. The relation between time and distance is given as t is equal to ax square plus alpha x square plus beta x. Okay. I'll do one thing. From this equation, I'll try to eliminate x, because if you look at the options, I don't have x in it. Is that right? So if I have to eliminate x, then I can say 1 minus beta times v is equal to 2 alpha x into v. Okay. Then what is going to be the value of x? 1 minus beta into v divided by 2 times alpha into v. So this I can call it as equation number 1, and this I'll call it as equation number 2. If I use 1 and 2, what will I get? I need to find this a. So I will do one thing. 0 is equal to a into 2 alpha x plus beta plus 2 alpha v square. This I'll call it as 2. Did you understand what I did? I took out a common. So 2 alpha x plus b square, 2 alpha x plus beta plus 2 alpha b square is equal to 0. So from this, what I can say is 0 is equal to a into 2 alpha into, in the place of x, can I use 1 minus beta v divided by 2 alpha v? Can I do this? Plus beta plus 2 times alpha v square. So what will get cancelled? 2 alpha and 2 alpha are gone. A into 1 minus beta v divided by v plus beta plus 2 alpha v square. So A, I can write it as minus 2 alpha v square, or 1 minute. A into 1 minus beta v plus beta v divided by v is equal to minus 2 alpha v square. Accepted? I took LCM. Okay, and I took this 2 alpha v square to the left hand side. Beta v and beta v are gone. So A divided by v will be equal to minus 2 alpha v square, which implies A is equal to minus 2 alpha v cube. Let's check if there is an option. So it is 2 alpha v cube. I didn't have a minus sign because in the question itself they use the word retardation. Retardation is negative acceleration. I hope it's clear. It's a good problem actually. Right? Suggest you want to copy it. There is any doubt in any step, please reach out. Which part? Okay. So 1 is equal to alpha is a constant. They have given it the question. Alpha and beta are constants. So constants, when they are multiplied with the variable, you will not differentiate. Alpha into, what is the derivative of x square? 2x into derivative of x, dx divided by dt. Because I did the differentiation with respect to time. Had I done the differentiation with respect to x on both the sides, okay. Suppose you wanted to approach the same problem in a different way. You wanted to differentiate on both the sides with respect to x. Then what would have happened on left side is dt by dx would be equal to alpha into, now you will not apply chain rule because you're differentiating with respect to x only. Then it would have been 2x plus beta. Actually, this will save time. I think this can be done faster. I went in a reverse way. You first finish it. I got an idea. You first finish it. I'll tell you an alternate way where you can solve the same problem in 3 to 4 steps. Because d square x by dt square is what is acceleration. That is why differentiate. See, more than this problem, now I hope you're getting an idea of why we are using differentiation, right? Where it is useful is in these kind of problems where the displacement is a function of time, means it's a non-uniform motion. Yesterday, when I discussed the derivation, do you remember I told you whenever you use non-uniform motion, right? Non-uniform motion or non-uniform acceleration, especially at that point, we need to go with calculus. So that is why we always concentrate only on instantaneous values. Okay. So these kind of problems you can expect in competitive exams. You're preparing it. Start doing it. You're doing for me. Those who are online, how many of you are preparing for competitive? Abhinav, Hariharan, Lokita.
Can you repeat that, sir?
I'm asking how many of you are preparing for competitive exam as well, JEE or NEET, whatever it is. None of you.
Sir, I don't know, sir. I'm thinking about it.
Sir, I am preparing, sir. I want to prepare.
Okay. Because these kind of problems are a part of competitive exams as well. You'll often find it. That is why I wanted to solve MCQs first. This panita CBSE is very easy. Right? So I hope you're done copying it. Still doing the check. Did I skip anything? Is it fine? Shall we see an alternate way to solve the same problem? So what is the equation? T is equal to alpha x square plus beta x, right? So now what we'll do is differentiate with respect to x on both sides. When you do that, you will get dt by dx is equal to 2 alpha x plus beta. But what is dt by dx? It is 1 by v is equal to 2 alpha x plus beta. So 2 alpha x is equal to 1 by v minus beta, or this can also be written as 1 minus b beta divided by v. So x will be equal to 1 minus b beta, 1 minus beta v divided by 2 alpha into v. Let me call this as equation number 1. Okay. Or else I can do one more thing. So you got this, no? 1 by v is equal to 2 alpha x plus beta. Again differentiating 1 on both sides with respect to time distance. This time you'll do it with time. So what you will get is minus 1 by v square, because derivative of 1 by x is minus 1 by x square. So derivative of 1 by v will be minus 1 by v square into dv divided by dt is equal to 2 alpha into dx divided by dt. Okay, what is dv by dt? A is equal to 2 into alpha into dx by dt is v. But don't forget you have a v square here and the minus sign I'm pushing it to the right hand side. From this I can say A is equal to minus 2 alpha v cubed. So the same problem could have been solved like this also. Is it clear? So once I differentiated with respect to x, the second time I differentiated with respect to t. When I did the second time, I applied chain rule. Clear? So moving on to the next problem. So approaching each other is a relative velocity based problem. Fifth one. A particle is thrown vertically upward. Find its velocity so that it covers the same distance in the 5th second and 6th second. Okay. So for that, we need to know the formula. Distance covered by an object in nth second. Okay. So the formula is Sn is equal to u plus a by 2 into 2n minus 1, where n is the nth second. So here the point that you're supposed to notice, this formula is not applicable for the object traveling in n seconds. In n seconds, na, between 0 to n. Nth second meaning n minus 1 to n. That is the meaning. So this is the formula. Now the question is, how did we get this in the first place? For that, I'll calculate the distance traveled by the object in n seconds. So what is the distance traveled by the object in n seconds? Un plus half into an square. What did I apply? Ut plus half at square. So try to understand the difference. If I put n in the bracket of s, then I call it as the distance traveled by the object in n seconds. If I put a subscript n, then I say distance traveled by the object in nth second. So this is for nth second. This is for n seconds. Okay. So S of n minus 1 will be what? U into n minus 1 plus half into a into n minus 1 the whole square. So if I am able to calculate S of n minus S of n minus 1, then I'll get the distance traveled by the object in the nth second. So for that, what I will do is S of n is equal to un plus an square by 2 minus S of n minus 1 is un minus u plus half into or a by 2 into n minus 1 the whole square. Okay. Now what will happen is this un and un will get cancelled. So minus of minus u is going to be plus u plus a divided by 2 into n square minus n minus 1 the whole square. So if you observe this, you get u plus a divided by 2 into 2n minus 1, and this is going to be the distance traveled by the object in the nth second. Is the point clear? Make a note of this.
Okay. Yes, sir.
தெரியுமா formula? எனக்கு கேட்கல என்ன மாஸ்க் இஸ் பிளாக்கிங். இதுவா? Hey, distance traveled by object in nth second. Formula இருக்கு. Do you remember? Right? So what did they say? What should be the initial velocity so that the distance traveled by the object in 5th second is equal to the distance traveled by the object in 6th second. So which implies u plus acceleration is actually when the object is thrown upwards, the object experiences an acceleration in the downward direction. What is the g represented for? You call it as acceleration due to gravity. Yesterday I told you, remember, whenever you're dealing with vector quantities, if you take one of the directions to be positive, other should be negative. For example, in this scenario, if you're taking the upward direction to be positive, this you can take it to be negative. Is that clear? So u plus, instead of plus, I can use u minus g by 2 into 10 minus 1 is the same as 1 minute wait. Find its velocity. Initial velocity is going to be the same only. U is getting cancelled. So, the second it is going to cover u minus g by 2 into 10 minus 1 plus u minus g by 2 into doesn't make sense. Which velocity are they asking? Find its velocity. The particle is thrown vertically upward. Okay, accepted. Find its velocity so that it covers same distance. So this is the formula. That also you can do, but you need to know what is the velocity at that point. If you come to rest only at maximum rate. 5th and 6th second, it's still traveling now. First, let's do one thing. First, this problem has to be thought in a different way. I'll tell you. First, we'll try to find out how much distance the object has covered in 5 seconds and how much distance the object has covered in 6 seconds. For that, we will apply the formula v square or v is equal to u plus at. So when I apply v is equal to u plus at, when an object is thrown from the bottom with initial velocity u, it decelerates with an acceleration of, it decelerates with the value of g. And by the time it reaches the maximum height, the velocity of the particle at the highest point will be 0. So this distance, if you are able to calculate, So if you're able to know at what instant the object has reached the highest position, then you will get clarity of what is happening in the 5th and the 6th seconds. So if I put v is equal to 0, u is how much? That's what we need to find. Minus g into t is, actually this also doesn't make sense. So t will be equal to u divided by g. But the logic here is don't vertically upward, find its velocity so that it covers the same distance in. Makes sense. Because u is getting cancelled. You know what I wanted to actually find is, I wanted to understand where the particle is at the 5th second and where the particle is at the 6th second. But the data given here is insufficient. But it's not helping to solve. So u plus a by 2 into 2n minus 1. Just a minute, let me check. Let me think about this. Sixth one. We'll come to the 5th again. So there is a particle which has a velocity of v is equal to 16 plus 0.1 t square. Then it has. So they are concentrating on acceleration. For acceleration, do dv by dt. dv by dt is how much? So 0.2 times t. So this is acceleration. If you observe, acceleration is a function of time. When acceleration is a function of time, I cannot call it as zero acceleration. I cannot call it as uniform acceleration. I cannot call it as uniform retardation. So the answer is non-uniform acceleration. So what is the meaning of non-uniform? The acceleration will be a function of time. That is answer. The answer is C. So what will be the explanation you will write? Since A is a function of time, we say it is a non-uniform acceleration. Right? Got it? See, for the previous problem, we can think something like this. So distance traveled by the object in the 5th and the 6th second are equal. Remember, when the object is accelerating, okay, I repeat it, when the object is accelerating, that is A is not equal to 0, then can I say that it does not follow uniform motion? So when acceleration is not 0, it is a non-uniform motion. This is accepted. Now, when you say distance covered by the object in the 5th second and 6th second are the same, right? In the case of a non-uniform motion, when can that kind of a scenario even occur? Because what does uniform motion tell you? Uniform motion says that the object covers equal distances in equal intervals of time. So if S5 should have been equal to S6, the object should have moved under uniform motion. But in this scenario, it is not under uniform motion. Why? Because there is acceleration due to gravity existing. The object is accelerating or decelerating. So when the object goes from bottom to top, it is decelerating. Why did I say decelerating? Because velocity and acceleration are in opposite direction. Whereas when the object is moving down, its velocity and acceleration, they both are in the same direction. So it is accelerating. Is that right? So in the case of a vertical motion, for S5 and S6 to be equal, then what should have happened is if you take this to be the maximum height, then S5 would have been the distance traveled by the object before it reaches the maximum height. So if this is the distance traveled by the object in the 5th second in the upward direction, then in the 6th second, the object should have traveled in the downward direction. Is this logic clear? Only then you can say that they will cover equal distances. Means when the object is moving in the upward direction, you cannot say the distance covered by it in any of the nth second is not going to be the same. Means distance covered in first second, second second, third second, everything will be different. So if two distances are equal in the case of vertical motion, what can you say? One should be an upward motion and the second should be a downward motion. So for S5, what I will do is I will write U plus A by 2 into 2n minus 1. So in the place of n, what am I going to substitute? 5. So I'll write it as 10. And in the place of A, I will write it as minus G. Right? U minus 9G by 2. Right? Let this be equation number 1. Displacement of the object in the 6th second is what? U minus G by 2 into 12 minus 1. Accepted? Because 2n minus 1, 2 into n, it will be 6. So it is going to be U minus 11G divided by 2. Let this be equation number 2. Right? But S5 is in upward direction. So if you take upward direction to be positive, S6 should have been negative. So what will happen is S6 is actually minus U minus 11G by 2. Now this displacement is equal to S5. So from this what I can conclude is minus of U minus 11G by 2 will be equal to what is S5? U minus 9G divided by 2. So minus U plus 11G by 2 is equal to U minus 9G by 2. So rearrange the equation. 2U is equal to 20 times G by 2, it will be 10. So 10 into G is 9.8. So 10 into 9.8 is 98. So 2U should be equal to 98, which implies U is equal to 14. So what we wrote is right, except the fact I didn't connect to that logic. Is this clear? Make a note of this. You're done copying. Written. So there is a car which starts from rest and moves with a constant acceleration. So A is constant. Distance traveled by the object in n seconds, if I call it as Sn, and distance covered by the object in n seconds, if I call it as S of n. They are asking what is Sn to S of n. For that, Sn, what is the formula? U plus A by 2, 2n minus 1. So U is how much in this scenario? It starts from rest. So U is 0. So this is going to be A by 2 into 2n minus 1. This is what is Sn. Let this be equation number 1. What is S of n? Un plus half into an square. But un is again 0. So this will be an square divided by 2. This is equation number 2. Divide both. Sn divided by S of n will be equal to A by 2 into 2n minus 1 divided by an square by 2. 2 and 2 are gone, a and a are gone. So 2n divided by n square minus 1 divided by n square, or 2 by n minus 1 by n square will be the required answer. Option B. Eighth one. A person throws some balls into the air after every second. The next ball is thrown when the velocity of the first ball is 0. How high does the ball raise above his hand? So a person throws some balls into the air every second. The next ball is thrown when the velocity of the first ball is 0. When will the velocity of first ball be 0? Just now I gave you a hint. When it reaches the maximum height. So after every second, for every second the ball is being thrown, it is reaching the maximum height. Means the velocity is in that way. The next ball is thrown when the velocity of the first ball is 0. How high do the balls raise above his hand? Means if the ball is thrown from here, This is the point at which the velocity becomes zero. For this to become zero, it has traveled maximum height, and the time it takes to travel maximum height is 1 second. That's what they've given, right? So for that, what I will do is I'll apply v is equal to u plus at. So what is the velocity at the highest point? Zero is equal to u plus acceleration due to gravity is minus g, and the time taken is 1 second. So from this, I can conclude that u is equal to g. Means if the object is thrown with an initial velocity equal to the acceleration due to gravity, it will take 1 second for it to reach the maximum height. Okay. Now, if this is the case, what would be the maximum height is what they're asking. So for maximum height, I am applying the formula v square minus u square is equal to 2as. So v square minus 0 square, sorry, 0 square minus, yes, g square is equal to 2 into minus g into h max. So minus g square is equal to minus 2g into h max. This will get cancelled. G and g will get cancelled. H max will be equal to g divided by 2. If you take the value of g as 10, because I'm not able to see any decimals in the option, if I take g to be 10, it becomes 10 by 2, which is 5 meter. So it reaches a maximum height of 5 meter. This is clear. So this one we'll do next. Do the 10th. If a ball is thrown vertically upwards with a speed u, the distance covered during the last t seconds of its ascent is. Ascent means the object is traveling in the upward direction. So ball is thrown vertically upward with a speed u. The distance covered by the object in the last t seconds of its ascent. For that, you need to know how much time it is taking for the object to reach the maximum height. So how much time will it take to reach the maximum height? For that, you can apply the formula v is equal to u plus at. V is how much? 0. U is u only minus g into t. So t will be equal to u divided by g. Is that right? So they're asking what is the distance traveled by the object between the time u by g and u by g minus 1. So Sn is equal to u plus a by 2 into 2n minus 1. So u is u only minus g by 2 into 2 into n is u by g minus 1. So this will be equal to u minus g by 2 into 2u by g plus g by 2. So g and g are gone, 2 and 2 are gone. U and u also get cancelled. Answer will be g by 2. So it has covered a distance of, oh, they want the answer in terms of t here. Okay, then we don't need all these things. Ball is thrown vertically upwards at the speed v, the distance covered during the last t seconds of its ascent. So this t seconds, right? So when I apply s is equal to ut plus half at square, I get s is equal to u into the time taken by the object to reach the maximum height is t only minus g by 2 into t square. Is this point clear? Okay. Then what about s of t minus 1? That will be u into t minus 1 minus g by 2 into t minus 1 the whole square. But this is also supposed to give you the same formula only, u plus g by 2 into 2n minus 1. Ball is thrown vertically upwards. Distance covered during the t seconds of its ascent. Okay. Do one thing. Try to find out what will be the velocity of the object at t minus 1 seconds. Find the velocity of the object at t minus 1 second. Apply the formula v is equal to u plus at. You will get u minus gt. But the t you don't know what it is. Okay, I got an idea. Wait. Thing is, see, if I take the formula Sn is equal to u plus a by 2 into 2n minus 1. I can apply this only when I know the object's movement in the nth second. So nth second exactly means n minus 1 and n, means it is only one difference. The time difference between them is only 1 second. Whereas if you observe this equation, they are saying in the last t seconds. So let's say the object is projected from here and the time of ascent, how much did we get it? We derived it, u by g. So time of ascent, so initially we did know, we got u by g, the time taken by the object to reach maximum height. V is equal to u plus at, we applied the time taken by the object to reach the maximum height. Okay, v and it will be 0 is equal to u minus g into, let's say this is the time of ascent, ta. So time of ascent will be equal to u divided by g, correct? Are you clear with what I'm saying? Say, but t seconds now, last t seconds now, this will be the distance traveled by the object in the last t seconds. Okay. Then what will be the distance traveled by the object here? It will be in how much time? Time of ascent minus t seconds. So to cover this much distance, it is taking ta seconds. This is the distance covered in small t seconds. Then how much will this distance, how much time would it take to cover this distance? The total time to reach the maximum height minus the last t seconds, other than ta minus t dash, or t, whatever you call it. Okay. So if you're able to calculate the height of the distance traveled by the object in ta seconds, how much will you get? You will get u into ta minus g by 2 into ta square. Is there any doubt in this? So if you call this height as, let's say it is h dash. So if you call this as h dash is a distance traveled in t minus ta seconds. So sorry, ta minus t seconds. Am I right? So this will be equal to u into ta minus t minus g by 2 into ta minus t the whole square. Can I do this? Yeah. So what is the distance they are asking? This is h minus h dash. And this whole thing is h, and the smaller part is h dash. So h minus h dash, if I try to calculate, I'll get u into ta minus g into ta square by 2 minus u into ta minus ut minus g by 2 into ta square plus t square minus 2 into ta into t. I just applied basic algebra. So UTA will get cancelled. GTA square by 2 and G by 2 TA square by 2 will get cancelled. So what are we left out with? I'm left out with UT minus GT square by 2 plus G by 2 into TA into small t. Does it make sense? Right. So this should be equal to UT minus GT square by 2 plus G by 2 into what is the value of TA? U by G. U by G into small t. So G and G will get cancelled. 2 and 2 will get cancelled. So what I left out with? UT minus GT square by 2 plus UT. Did I do any mistake? Minus of minus is plus. So this will be plus. This will be a minus. So either plus. This is a minus. So UT plus GT square by 2 minus UT. So UT and UT are getting cancelled. GT square by 2 will be the answer. Is there an option? But did you understand what I did? I repeat the logic. So ball is thrown vertically upwards with some speed u. Okay. So initially when we started, the mistake that I did is I calculated what is the distance covered by the object in nth second. It is not the nth second. It is in t seconds. Nth second, what is the difference between t seconds? Nth second, exactly between n minus 1 and n. Here, when they say t seconds, I exactly don't know how much is the t second, whether it is 1 second or 2 seconds, I don't know. Nth second, the distance should be only for 1 second. Fifth second meaning the distance traveled by the object between the fourth and the fifth second. Breathe. Right? So you understood what was the mistake I made? Now, what I did is the approach was first I tried to calculate how much time it will take to reach the maximum height. Why did I even concentrate on maximum height? Because I use the word ascent. So ascent, now the object is traveling in the upward direction. I wanted to know how much distance it has covered in, how much time it has taken for the object to reach the maximum height, and I got it as u by g. Okay, and it took the time of ascent. So they use the word distance covered by the object in the last t seconds. So if this is the time taken for the time of ascent, last t seconds, let's say it has traveled this much distance. So this distance is the maximum height traveled by it. And this distance is the one which is traveled by it in the last t seconds. So what will this distance be? It will be the distance traveled between the time of ascent minus the last t seconds. So I calculated this. I calculated the maximum height, subtracted both. I got the answer as gt square. So logic is this. If you observe the way we are solving problems, we are not applying anything outside equation of motion. And I'm able to do that because the object is still traveling under a constant acceleration. When the object is moving near the surface of Earth, the acceleration due to gravity is a constant. Other than I'm able to apply those equations. Am I clear? So make a note of this. Am I clear to people who are online?
Yes,
sir.
sir.
Am I clear? Which steps? This is okay. Shall I move up for you to copy? Yeah. Right. So relative velocity we can't do. Can you try this 12th one? Okay, try to. So read the question carefully and then do it. The student is standing at a distance 50 meters from the bus. As soon as the bus begins its motion with an acceleration of 1 meter per second, the student starts running towards the bus with an initial velocity with a uniform velocity. Means the student, when he is running, he is not accelerating. Assuming the motion to be a straight road, the minimum value of u so that the student is able to catch the buses. So let's say this is where the bus is. Okay. And it started at t is equal to 0. As soon as the bus begins its motion, means initial velocity of it was 0. Right. Let's say this is the place where the student got into the bus. But where was the student initially? He was 50 meters behind. Right. He was 50 meters behind. And let's say the bus has traveled a distance x in time t. So in the same time t, the student should have started with some initial velocity, assuming that the motion, the student starts running with towards the bus with a uniform velocity u. So what is the distance covered by the boy or distance covered by student? What is the distance covered by student? It is 50 plus x. So can I write this as u into t? So in the same time t, both started. The student also started, the bus also started. So 50 plus x is equal to ut, which I'll call it as equation number 1. But the bus is accelerating. Bus is accelerating with 1 meter per second square. So what is the distance covered by the bus? Half into s is equal to ut plus half at square. So s is x. Initial velocity of the bus is 0, time is t plus half into acceleration into t square, which implies x is equal to at square divided by 2, which I'll call it as equation number 1. Can I do this? So if I take this x and substitute it here, 50 plus at square divided by 2 is equal to u into t. But what is the value of a? A is 1. Did you read the question carefully? Acceleration is 1 meter per second square. So I can write t square minus 2ut plus 100 is equal to 0. Can I do this? Yes. Okay. Now the next question is t is equal to minus b plus or minus root of b square minus 4ac divided by 2 times a. What did I apply? The quadratic formula x is equal to minus b plus or minus root of b square minus 4ac divided by 2a. Is it clear? So this will be equal to, now for time to exist, for this time to be a real value, what should the discriminant be? Discriminant should be strictly greater than or at the max equal to 0. So if that is the case, 4u square minus 400 should be greater than or equal to 0. Is there any doubt in this? So 4 will get cancelled, 100. So u square is greater than or equal to 100, implies u is greater than or equal to 10. So what is the minimum value? Minimum value of u should be 10 meter per second. Maximum can be anything. Means if the boy has to catch that bus, if the student has to catch that bus in that stipulated time, then the minimum velocity with which he or she is supposed to start is 10 meter per second. That is what they asked in the problem. What is the minimum velocity with which he needs to start? Okay. The problem stuff slightly clear. 11th, it is like that. Even your NCERT problems are like this. But you're able to understand the logic, so that is more important. Right? Yeah. So clear, right? I think we can stop with this problem. This will be the last. Okay. See, you guys copy it. But before that, students, those who are online, any doubt?
No, sir.
Okay. I hope you all copied this problem. Yeah. So units and measurements test will have it. Next week, you'll have too many tests. We'll have it the week following it. Because next week, you already have math on Monday, chemistry on Wednesday, right? You people asked for time. You didn't want it tomorrow. Chemistry on Wednesday. So next week we'll not have physics. Physics will have it on next Monday. Next week also I'll do one more class. I'll solve problems of this sort. And then I'll explain the concept of relative velocity. We'll do problems based on them also. And we can go to the next chapter. Next Friday we'll start vectors, motion in 2 dimensions. So what is going on in school for DAV? Motion in a straight line. This chapter only. Now you'll be able to answer better. What about you? So you're able to answer when they're asking questions. What about other school? Sunshine, what is happening? Are you? Okay. That's it. We'll wind up. Okay.